At the secret Oakland Raiders training facility. The Raiders football team comes here to practice on their secret training field, work out with weights, negotiate contracts, and hold press conferences. But we're here today to do some carpool chemistry. Today we're going to learn how to calculate the limiting reactant of a chemical equation. Let's say you're given the reaction of zinc with hydrochloric acid to form zinc chloride and hydrogen gas. And let's say you're given only 2.5 moles of zinc and only 6 moles of hydrochloric acid. We want to find the limiting reactant, that is, which runs out first, zinc or hydrochloric acid. Step 1. First, you calculate the moles of the product form if all of the first reactant, zinc, is used up. Let's use dimensional analysis, or want is equal to have times factors. Underneath want, what do we want? We want our moles of product. Now we have two different products, zinc chloride and hydrogen. As long as you choose one or the other and stick with that same product throughout the problem, you'll be fine. You need to be consistent. I'm going to use zinc chloride just because it's the first one that comes up. Moles of zinc chloride is equal to, what do we have? What's going to be driving the amount of product of zinc chloride that's formed? Well, in this case, we're going to be using up all of our zinc, or 2.5 moles of zinc. There's 2.5 moles of Zn times, and then what's the factor that relates moles of zinc to moles of zinc chloride? We get that factor, of course, from our balanced equation, where it's a 1 to 2 to 1 to 1 ratio. So the moles of zinc chloride to moles of zinc is a 1 mole to 1 mole ratio. Let's write that down. 1 mole of zinc chloride for every 1 mole of zinc. Notice how we wrote the zinc chloride on the top and the moles of zinc on the bottom, so the moles of zinc cancels out, leaving us with moles of zinc chloride. Doing a simple calculation gives us 2.5 moles of zinc chloride are formed. Now let's do step number 2. Step 2. Calculate the moles of product form. This time, if all of the second reactant, which in this case is HCl, is used up. Let's use dimensional analysis again. Want is equal to have times factors. Underneath want, we still want the same product, moles of zinc chloride. Notice I stuck with zinc chloride, is equal to, and what do we have in this particular case? Well, now our driving factor is the moles of hydrochloric acid, which is 6 moles of hydrochloric acid. Notice how I didn't say 2 moles of hydrochloric acid, because this 2 here represents not the actual amount, but the ratio between hydrochloric acid, zinc chloride, and hydrogen. So underneath have, we write down 6.0 moles of HCl times, and once again from our balanced equation, we're looking at 1 mole of zinc chloride to 2 moles of hydrochloric acid. So we have 1 mole of zinc chloride for every 2 moles of HCl. And just to leave myself a little reminder of where I got this from, I'm going to leave myself a little note from the balanced equation. And I'm going to do the same thing up over here. This came from the balanced equation. It's like leaving a trail of breadcrumbs to yourself through the forest so you could find your way back. Equals, and in this case we have 3.0 moles of zinc chloride. Now that we know how much product each of these reactants will form if they were able to be used up, we tie them together with a final statement. And we write down, we have enough HCl to form 3.0 moles of zinc chloride that we calculated from right over here, comma, but we only have enough zinc, our first reactant, to form 2.5 moles of zinc chloride. Therefore, the zinc runs out first. It is the limiting reactant. And that's how you determine the limiting reactant of a chemical equation. Now, sometimes instead of giving you moles and moles, they're going to give it to you in grams. If they do that, easy. Same procedure, but before you can run through this process, you just need to convert your grams to moles using molar mass, and then you use your balance equation to determine the limiting reactant. So that's how you determine the limiting reactant. From the secret Oakland Raiders training facility, this is Carpool Chemistry. Thanks for watching.